Hello class, today we can continue learning to draw angles in standard position. So, last time we learned to draw an initial arm that's always on the 0 degrees axis. Then there's the principal angle that we're concerned about, which is formed with the terminal arm, shown in purple here. And then there's the other angle, which is beta, which is our related acute angle, which is always drawn from the terminal arm to the x-axis, whether that's the 180 degrees axis or the 0 degrees axis. And then we also learned that we can draw a right-angled triangle with our related acute angle using the terminal arm, where if I draw from the terminal arm down to the x-axis, we can make a right-angled triangle. And so this right-angled triangle encases the related acute angle, and we can also figure out the side lengths. So for the opposite side length here, if there was a point on this terminal arm with the value of x and y, the value of our opposite side length is our y value, because it would normally be, according to our Cartesian plane, the amount of distance up the y-axis. For our adjacent side, this side length is given by our x value from our point. And to get the hypotenuse, we would use the Pythagorean theorem, where we would take our x squared plus our y squared to get our hypotenuse, which in this case we'll determine, we'll use a variable r for a radius. So r squared is equal to x squared plus y squared. So to get the value of the hypotenuse, we take the square root of x squared plus y squared. Now, recalling that this unit deals with the trig ratios, you know the trig ratios as the sine of an angle is equal to the opposite over hypotenuse, the cos of an angle is equal to adjacent over hypotenuse, and the tan of an angle is equal to opposite over adjacent. But as you can see, the angle that we're concerned about, the principal angle, doesn't have a right angled triangle. Instead, the related acute angle has a right angled triangle. And it turns out that if I can figure out the trig ratios of this related acute angle, it's going to be the same as the principal angle. So, for the sine of the theta, I'm really looking at the sine of beta. And that would be, in terms of the x and y coordinates of the point, would be, so the opposite side length is y, hypotenuse side length is r, so that's our sine of beta. The cos of the beta is equal to the adjacent side, which is x, over the hypotenuse, which is r. And then the tan of the angle, beta, is the opposite, which is y, over the adjacent x. So if we find the trig ratios of the beta, the related acute angle, I can actually come about with the angle, the trig ratios of the principal angle that we're concerned about. The only difference is that the related acute angle is always going to be positive. The principal angle ratios may or may not be positive, which we will learn in the next lesson. So, how are they related? Is that beta ratios are the same as the principal angle ratio. But beta is always positive. Whereas theta, the positive or negative ratios depends on the quadrant it's in, which we will learn in the next lesson. Okay? So remember this rule, that if we want to find the trig ratios of a certain angle, theta, we have to create a right angled triangle with the terminal arm and the x-axis, and find the trig ratios of our beta, our related acute angle, and then we can figure out the trig ratio of the principal angle.